Hello everyone and welcome to the lecture series on modern C++ for robotics, machine learning, and control engineering. In this tutorial on modern C++, we explain the basics of finite-state machines and how to implement them in modern C++ programming language. Finite-state machines are very important for the development of control logics for a number of physical and software systems. They're widely used in robotics, automation, flight controllers, computer games, etc. Knowing how to implement finite-state machines is of the paramount importance for control and robotics engineers. Let's consider the following example. Let's imagine that we have a press button that controls the motion of the robot. When the robot is at stop and if we press the button, the robot will move. Then, if you release the button, the robot will keep on moving. Then, if you press the button once again, the robot will stop. When we release the button, the robot should stay in stop state. We can model this required behavior by using this graph over here, which is known as the state transition diagram. Let's see what's happening over here. We have two states. We have stop state and we have move state. That is, our robot can be in two possible states. It can be at rest, which we model as the stop state, and it can be moving, which we model as the move state. Then we have some external inputs or actions. That is, a user can press or release the button. If the button is on, that is, if the user presses the button, the robot will go from the stop state to the move state. On the other hand, if you release the button, then the robot should stay in the move state. And this is represented by these transitions over here. Here's the first transition from stop to move, and then we have the transition which is only in the move. That is, we have a cycle. Now the robot is moving, and if the user presses the button once again, the robot should stop. That is, the robot should go to the stop state. And then, robot is at rest. If you release the button, this is modeled by this transition over here. Again, if the user from the stop state presses the button, the robot will start moving, etc. We can model this behavior by using this state transition table. Namely, we can put the current state, that is the state in which the robot is currently in, over here. And we have stop, stop, move, move. So let's analyze the first scenario. If the robot is in the stop state and if the button is off, then the next state, represented by this column over here, should be stop. And that's precisely this transition over here. That is, we are in the stop, button is off, and we should stay in stop. Next, let's analyze this row. If the current state is stop and the button is on, then the next state should be move. That is, we should go over here. So let's look again. We are currently in a stop, the action or the input is on, and the next state should be move state. Then we are currently in the move state, button is off, that is, the user releases the button, and the next state should also be the move state. Then we are in the move state, the button is pressed on, and then we go to the next state, which is the stop state. And this is represented by this nice table over here. That is, we can either use these graphs, which are known as the state transition diagrams or graphs, or we can use this table, which is known as the state transition table. The next important problem is how to code this in C++. And there are several approaches for doing that. The first is a simple C type of approach, and this approach is relying upon the switch statements. The second approach that we will cover in this video tutorial is the approach that uses C++ standard template library called maps, or one of the template classes which model maps, or it can be used to model tables, and classes. And the third approach, which is the most generic approach and the most robust approach, is to use abstract classes and inheritance in order to have a robust solution. This is known as the finite-state machine design pattern in C++. This is an advanced approach, however, we will also cover this approach in the future video tutorials. So let's briefly explain the main idea of C++ implementation, and then let's start with coding. So what is the first idea? The first idea is to define the state. For that purpose, people usually use enumeration class and then we state the state. Over here, we basically define the state, and inside of the state we have stop and move, right? Then we need to model the actions or inputs, and we model them enumeration class, and then we give it as a name, we give it button, and we have two states, on and off state. Once we have these two types, we can use maps. Here's how maps are declared and here initialized. Map is a member of the standard template library and models maps. We access maps by using the key value pairs. So here is the key. In our case, it's the state and button. That is, the pair consists of a tuple consisting of state and button. For example, these are these two columns of this table. And the next thing that we have is the next state. That is, this part over here represents the current state and the button, and this part over here of our map consists of the next state. And over here we can simply give the name of our state transition object, and over here we can initialize. That is, we will simply enter this table over here. So let's analyze what's written over here. First of all, here we have the pair. The first entry of the pair is the current state. The second entry of this pair is the current state of the button or the current input off. And then here we have the next state. The next state is stop. Here is the second row, and here is the initialization of the second row. That is, we have stop, on, and the next state is move. Then we have the state move, off, and the next state is move. That is this row over here. And finally we have move, button is on, and the next state is stop. And that's the basic idea. Later on, we will embed everything inside of the class, and inside of that class we will make transitions and we will do all sorts of things. This will be explained in the sequel. Okay, let's start with implementation. As you can see over here, I'm using Visual Studio Code as an editor, and I'm going to use the GCC compiler and the command line to compile the file. On my YouTube channel, you have a number of tutorials explaining how to install Visual Studio Code on Windows and Linux, as well as how to set up the GCC compiler on Linux and Windows. So let's start. First of all, I need to include the necessary libraries. For printing, I need IOStream. So let's type this for printing. Then I need map, since we will be using maps. Then I need utility. Utility is necessary for using pair. Then I need to include string, just in case if I want to define a string. And then finally, let's type this using namespace std, since I want to simplify the notation. Then let's define our main function and let's return 0. First of all, we need to define state. To define state, I will be using enum class data type, and then I will specify the name. That is, I will declare it as state. And inside our state has stop state and it has move state. Let's do the same thing for button. Button will be modeled like this. Enum class button, and then over here we have button. Two possibilities: the button can be on and the button can be off, and that's it. Let's save this and let's continue further. Next, let's define our state transition map. So let's type state transition map such that we know what we are doing. Okay, as mentioned previously, we are going to use the map container. So we will type map. The map contains two fields or two entries, the first entry and the second entry. The first entry will be pair. The pair, as the name suggests, is a container containing pairs. The first field or the first index is state and the second one is button. That is, first we have the current state and then we have the input, and through that we are going to access the next state. That is, this first entry is the current state, the second entry is the input, and over here the last map value, that is the field that will store the value, is state. Then let's give the name as state transition, and over here let's start. So let's do like this. Let's initialize the values here. Don't forget to add this and erase this. So let's be careful over here. Map initialization should model the state transition map. We have 4 rows and consequently over here we will have 4 entries. So let's denote the first entry like this. Let's denote the second row. Let's put it like this. The row is like this. The third row is here and the fourth row is here. Okay. While coding this, make sure that the declaration and initialization look nice, such that you can easily read. Okay. First of all, we need first 2 columns. So let's start like this, and then over here we have the next state. So let's start. We need state stop, and we can use the scope operator to define that. So it's state, then it is the scope operator, and over here we have 2 possibilities. We have the first possibility and the second possibility. Let's start with the first one, stop. So we are currently in the stop state. And let's do the same thing for button. Button is currently off. Oops, not here. I should be careful. It's over here. Button is currently off. And if that's the case, then the next state should be stop. And let's type it like this. Okay, simple as that. Good. How about the second row of our state transition table? The same principle applies. Here I'm copying and pasting the second row. So let's see. We're currently in the stop state. The button is being pressed. The next state will be move. Good. Let's see what's happening with the third row. We are currently in the move state. Let's type this. The button is pressed. Our button is off. Then we will keep on moving. And finally, we are over here in the move state. Someone pressed the button, and the next state should be stop, and that's it. Here you can double check this table and make sure that everything works as it should. So let's do it together. We have stop state, current state, button is off, the next state will be stop. The current state is stop, button is on, the next state is move. The current state is move, the button is off, the next state is move. The current state is move, the button is on, the next state is stop. That's it. Let's save this and let's continue. Next, I need to define 2 additional maps that will help us to print the current value of state and the current value of the button. So let's do it. Here is the first map. The key will be state and the value is a string. I will call this map as print state, and let's see what do we have inside. We have 2 entries. If the current state is stop, then I want to print out stop state. So let's implement that. So the state, then the scope operator, stop, and then I need to type this, stop state. Later in the code, when this is detected, we will print this message, and you will see later on the implementation. Let's do the same thing for the next state, that is for the move state. Then we type here move state, and let's type something like this. Good. Let's do the same thing for the button. So we have map, then we have button, then we have the string that we want to print. And over here, I need to type print action. Okay, so let's type this. And let's see what do we have inside. If the button is on, we will simply print the message as button on. Okay, then comma, and over here is the second part. If the button is off, we will simply print out button off. You will see later on in the code how we are going to use these two maps. Next, I'm going to declare and define a class that will store the state and that will help us to manipulate the state. So let's start. I will call this class as class robot motion. Here it is. So let's see what do we have. Let's see what is under public and what is under private. This class will store the current state. Consequently, I will type something like this, state, current state. Good. Let's see what are the constructors. We will have only a single constructor, so let's type robot motion as a constructor over here, and let's see what has to be written inside. I'm going to simply set the state as stop. That is, when we instantiate the object of this class, the state will be set as stop, since we want to start from the stop state. Then I need to provide a functionality, that is, I need to implement a function that will change the state when a button state is being changed. For that purpose, I'm going to define a function called button action. This button action function will receive the current value of our button. I will call it action over here, and let's see what we need to print. So let's print this, cout previous state, and then let's print the previous state. So how do we do that? Since we model the state as a map, we can simply type this, print state, right? However, not exactly as a map. Here we are just using this auxiliary map called print state, which will enable us to print. And then over here we can simply type current state. And then we can do end to end the line. Okay, simple as that. So we want to first inform the user that we were in this state. Then we need to print the action. So let's now type this, cout received action, and then let me just leave spaces here. Then we can say print action, and then we can simply pass the current value of action, and let's end the line over here. Good. Let's continue further. Now we need to do the state transition. How do we do the state transition? Well, we need to use the state transition map. Here it is. Let's do this. First of all, current state will be, which is our next state to be more precise, will be state transition, and then what do we pass? We pass a pair of current state, let me now copy it here, and the value of action, and that's it. So what will happen right now? For example, if the current state was move and the action was on, so what will happen now? Move, and if the button is being pressed, we simply go here in this table, state is move, button is press, the next state will be stop. This next state will simply be stored in the current state, and that's it. And then again, we can simply type this, we can copy this, we can say current state, and then we can simply print out. And that's it. Simple as that. And you can see how nicely we have embedded everything. Let's now go to our main function and let's start with testing the code. So what do? First of all, we type robot motion. We call it as motion1 over here. And then what do we type? We type motion1, then we type button action. And what do we want? Let's start and let's test the complete table. Currently, when we created the object, the state was stop. Then let's do button off. The state shouldn't be changed. Okay? Then let's do the second test. Button is now on, and our next state should be move. Then again, let's do off. It should stay in the move state. And finally, over here, we have button on, and this should stop everything. Let's save this, let's try to compile this, and let's test this code. Before we compile this file, let's improve the code a little bit. Namely, after we print the current state, let's just print the end line, just to make sure that we nicely print everything. So let's save this and let's continue further. Now we are ready to compile. To compile the file, I opened a terminal or a command prompt and I navigated to my folder, and here's the file. To compile the file, I'm going to use G++. Here I'm specifying G++. I want all compiler options with this G option, which is also another useful option, the name of the source file, and the name of the output file with this parameter O. This parameter O means that we are specifying the output file. And here it is. And then let's run the executable FSM, and we can see. Okay, previous state, stop state. Received action, button off. The current state is stop state. Correct. Previous state, stop state, button on. Next state or current state is move state. Previous state is move state, button is off, we are still in the move state. Previous state is move state, button is on, and then we are in the stop state. Simple as that. This means that the code works perfectly. Okay, that's all for today, and thanks for watching.